Before we get into the mechanics, hit that subscribe button and share this with anyone serious about history or survival techniques. What you're about to learn isn't just an interesting anecdote from Cold War archives. It's a practical system that allowed bunkers and underground shelters to remain structurally sound for decades, and it's knowledge you can apply today to protect timber in extreme conditions. During the Cold War, engineers faced a unique challenge: how to make wood survive underground for decades in environments constantly exposed to moisture, poor ventilation, and potential fungal or insect attack. Bunkers, missile silos, and command centers often relied heavily on timber for structural support, yet untreated wood exposed to these conditions would rot within a few years. The solution was a combination of chemical treatment, strategic design, and careful environmental management, a formula that allowed these structures to outlast their intended lifespan. So, during the Cold War, engineers actually started with chemical preservation. Unlike the pressure-treated wood we see nowadays, they used good old oils, tars and natural resins to protect their timber. Heavy linseed oil, sometimes mixed with pine resin or tar, would form this deep barrier that kept water out and stopped fungi from taking hold. They'd soak or coat the timber in several layers, letting each one cure completely before installing it. This method was especially common in Soviet bunkers, where, honestly, dealing with groundwater was just part of the job. For modern uses, any wooden structure exposed to dampness, like, say, raised garden beds, storage sheds, or even underground shelters, can really benefit from a similar approach. Applying boiled linseed oil or a resin mixture in several coats helps the wood resist moisture for the long haul. But, chemical treatment alone wasn't enough. Moisture control was absolutely critical. Engineers realized that even treated timber would eventually fail if it stayed wet all the time. That's why bunkers included things like ventilation shafts, drainage channels, and sloped floors, all designed to move water away from those wooden beams. The lesson here is simple. Environment matters as much as chemical treatment. Today, this principle can be applied by elevating timber off the ground, ensuring proper drainage around supports, and creating airflow in enclosed structures. Even basic adjustments like placing beams on concrete footings or gravel beds can dramatically extend wood lifespan. Layering also played a crucial role in preservation. Timber was often insulated with materials that absorb moisture before it could reach the wood. Dry sand, clay, or layers of tar paper were placed around beams, acting as a buffer against dampness. This system prevented rot from forming at the core of structural timber. For modern projects, lining shed bases or underground supports with coarse sand, gravel, or even old tar paper mimics this approach, creating a passive moisture barrier. Small steps like these replicate decades of Cold War engineering in your own backyard. Now, the type of wood used was another key factor. Engineers really preferred dense hardwoods such as oak or larch, since they naturally resist rot. Softwoods like pine or spruce, while easier to work with, were only used when combined with heavy protective treatment. For anyone serious about longevity, selecting the right species is, well, absolutely foundational. By combining naturally durable wood with chemical protection and environmental controls, they created an almost indestructible support system in Cold War shelters. Maintenance, while limited in some military installations, still played a role in extending the life of timber. Engineers designed systems that minimized the need for intervention, but where access was possible, periodic inspection and reapplication of protective coatings ensured survival. These days, modern applications are more flexible. Checking treated wood for early signs of wear or water infiltration and touching up oil or resin coatings can significantly extend lifespan. The principle really remains the same. Proactive maintenance complements the original preservation methods. So, you see, the combination of chemical treatment, moisture management, protective layering, careful wood selection and maintenance is really what allowed Cold War bunkers to remain functional for decades after their construction. Timber that might have rotted in 5 years above ground, well, it lasted 50 or 60 years underground. You know, understanding these techniques provides both historical insight and practical guidance for anyone dealing with timber in challenging conditions. Applying these lessons today can range from survivalist shelters to high-humidity storage areas. So, start with high-quality hardwood, apply multiple layers of linseed oil or resin, ensure water cannot pool around timber, use sand or gravel as a buffer, and check periodically for wear. This isn't just theoretical, it's a method proven over decades under some of the harshest conditions imaginable. If you found this guide valuable, make sure to subscribe and share it with fellow history enthusiasts and survivalists. The Cold War was full of forgotten engineering secrets, and understanding how they preserved timber gives us both a window into history and practical tools we can use today. On Thermal Vault, we'll continue exploring these hidden strategies, showing how lessons from the past can protect structures and resources in the present.